Hello and welcome to a little follow-up video. You could call this the part 26 of the UBIK solution. Well, I wanted to do this video because there are a number of ways I found to tweak this, and I basically wanted to share these things with you, as well as address a little issue that I became aware of that I kind of left out. I think I actually did mention it in one of the videos. So if we look at the, actually let's, it's easier to see if we just for a moment turn on the debug. So if we go into the character and check this draw debug, which will control whether or not the the debug lines are getting drawn. And then we can see that if we, for example, move the hand up like so, maybe it's more apparent in certain angles than others. Whoops. Well, let me try that again. Okay, so here you can see kind of that the lower arm seems to have a, yeah, here it's quite clear that the lower arm has a wrong angle. So one way I found to solve this, the reason for it is the fact that you can see this joint up here. This is supposed to be exactly at the clavicle or the upper arm joint, where that big ball of the character here is. But as you can see, it's a little bit off, and you could try and put it exactly where it is. That is one approach. What I did, and that is basically what I want to share with you now, is that I'm gonna change the order a little bit of the things that I calculate. So if we go into, let's see, solve arms, I believe it is. Yeah, because here we have here we set the clavicles after we calculate the lower arm and the upper arm. So what I'm going to do here is actually to cut this out completely, this entire thing with the clavicles. I'm going to cut that out, connect up this stuff again, and actually move all this in here. So while you have this in your clipboard, you want to go back and paste that into, actually first for these two, set shoulder, set left upper arm, let's paste it in here, the first part here. The left clavicle, paste that in here, and then cut this piece out with the right, and then paste that into the set right upper arm. And if you just, if you want to, at the end of this video, just want to reuse these things, these improvements, I would call them, as I'm doing here, you should definitely do that, because yeah, it's mainly going to be adjustments in this video. You can just grab it from the repository, you don't need to follow along. So we also need to, if we go back to the left upper arm where we pasted in the first part here, you can see we work off the world transforms here, but we don't actually set them at this point here. So what we're going to do here is to change this out to be, because the shoulder, the way the shoulder transform is oriented, it's okay to just do this. That's the best way I can really explain this. Because it's actually pointing upwards, as well as the world is also pointing upwards. So that's the reason we can get away with this. So what I'm going to do here is to take and substitute that. You can see we have the left arm, upper arm transform here, and the left upper arm transform, but this is in shoulder space, this is in wall space. So I'm going to drag this out here and break, and then take the location. No, actually not the location entirely. We're going to take the location and we're going to normalize that. I believe that is necessary as far as I remember. So we delete the bottom part here, and then we can just plug that directly into the X. Do we need to do this? No, we don't. We don't need to normalize this. We can just use this. This is not needed to be normalized. So the reason why we can get away with this is we treat the location as a direction in shoulder space. That is basically what we do here. So we are looking at the up vector and then the direction where the upper arm is pointing, or it's where it is relative to the shoulder. So that will give us the rotation, and we should do the same with the right as well. So substitute this part here, delete this, and connect this up and this. Okay, so we want to verify that it works still. So it does work, and you can see we haven't fixed the issue with the off angle here yet, but we just verified that it is working still. So the right, left and the right clavicles are still working. So the next part here is that we want to get set the exact position of this upper arm here according to where that joint is on the skeletal mesh, exactly where that is exactly. And the way we're going to do this is to go into the let's see, we're going to put this so we set the shoulder, we set the clavicle now. So we set the clavicle, and then we solve the arms. And it needs to be done before we solve the arms, really. That is kind of the deal here. So either I could put it after these two calls here, or I could just put it inside this solve arms. I think I'm just going to put it in here. So that means that we're going to have a preliminary adjustment of the left hand effector and the right hand effector location. Left upper arm, sorry, arm and the right upper arm. You know what? A little bit more clean way, or more obvious way to visualize this is to actually do another small function here. So let's call this reset upper arms location. So we're going to do this by getting owner, and the owner is the VR character in this case here. So we need to be sure that this is the get the cast tool. You know what? If I should make this a little bit more generic, I would probably do something like add an interface. So let's just do this just because we can. So I would add a blueprint interface. Call this VR character, and we would make a function called get mesh, which would return a skeletal mesh. Right, so something like this. And then on our VR character, I would go to class settings here and say add IVR character, and implement this function here. So in this case, I will return the skeletal mesh. Oops. What? Oh. Skeletal mesh component. There we go. All right. So now we can call this, which is basically what we want. And we can, instead of doing a cast to a specific VR character, we can do get mesh message. So we are sending a message to our owner to return our skeletal mesh. So what we do need to do though, and that is kind of a need here, is that we need to check if this returns something. Because if this UBIK component is not living on a VR character or something that implements this interface, then this obviously doesn't work. Is valid we want to call here. So we got this by an is valid here. And then if this is valid, if it's not valid, then we can't do anything. We should just should just live with it. We could maybe print out a statement or something, but let's not do anything at the moment. And then just drag this out here and say get socket location, and we want to get the upper arm left, and we also want to get the upper arm right. And then our, let's see, we need to convert this into, this is in world space, so we need to get the component, let me think here, no, wait, I need to get this in this shoulder transform, I believe. Because we're going to convert this into a shoulder transform, or shoulder space. That is the idea here. Because we're using these, if you remember, inside solve arms, these left upper arm transform is in shoulder space. So we need to get them into shoulder space. So we can just type in inverse transform location. This will convert from world space to local space. And that means that we're converting this world space location into this transforms local space. And that is exactly what we need. So we're going to set, this is the upper arm, and it's now in shoulder space. So left upper arm transform here. So we set this. And don't worry about setting the rotation because we don't need this for anything at the moment. So that's just fine. We need to set the right upper arm, right upper arm transform in shoulder space. And here we need to do the same, just with this one. Okay, and then we just need to call this before we solve the arms. So call this. So this basically makes sure that the arms are where they should be. So when we hit play again, it's completely off. What did I do wrong? Upper arm. Just going to check if this is valid. It is. What did I miss? Seems like the right. Is that right? Okay, right clavicle. Okay, so this is correct. Oh, geez, I forgot this, of course. Hope you spotted this faster than I did. I think I'm a little bit tired. So we need to convert this into shoulder space, of course. So there we go. Now you can see the ball here should be spot on, exactly where the shoulder is, and now the joint here is exactly where it should be. So no matter how you move it, it's going to be exactly where it should be. What you also want to test is that if the clavicle is still moving, and that was the reason why I had to move them. You can see the clavicle here is also moving. It's moving up. That was the reason why I wanted to move this up in front. So it's getting set here. So it's basically not getting calculated now based on the most recent transforms, but since it doesn't really matter that much, it's just one frame behind, it's going to be okay. Okay. So one other thing, so that was one of the fixes that I wanted to address here. So another thing that will happen once you start field testing this with a skinned mesh, which does not have these separated mesh parts as the mannequin does, like a human. For example, if you move your hand up here, I'm just going to copy this and hit stop, and then paste it in here, and then just rotate the hand so it's in a more natural position, something like that. Copy that, and oops, paste that, and maybe move it up a little bit further. Yeah, something like this, that will do fine. So what you can see here is that the if you look at the shoulder cap or whatever you call it, this part here, you can see it's pointing outwards, and it doesn't look completely wrong on the mannequin, but if you look closely on your skeletal mesh where he's in an A pose, you will notice that the shoulder pads are pointing outwards, and in our example you can see here they are also pointing outwards, but they should actually be pointing more or less upwards. So if you do something, take for example the upper arm here, and you raise your arm like this, this would more or less, it's not completely correct, more or less be the way it would look. Then you can see the shoulder pad is pointing upwards, and in our character at the moment it looks like more or less like this, I believe. Okay, that was maybe a little bit too much. Maybe something like this. And you can see that that is clearly an awkward position, but that is actually how he is posed at the moment. So we need to do something to fix this. The way I chose to solve this is to look at the hand position relative to the upper arm position, meaning this shoulder joint here, and see how far above that is it. So once I get above here, I will add some roll to this joint here, and once I get below, I will just leave it as it is, because it seems, well, it is, if you just rotate the hand in a more natural position, it seems like when it's below the shoulder, it's rotated correctly as it should. And you can play around with this yourself and see if you can get some better results out of this, but this is the way I chose to do it. Inside we're gonna do some calculations on that part that we just created. Let's see, that would be the solver arms. Left upper arm here. So towards the end here of solver arms, this long function here, we're gonna take the end here, the end here, and move out somewhat, something like this. And we're gonna take a look at the left upper arm for the left upper arm relative to the shoulder, the hand. Let's see. Let me just check something. The left hand vector here. Yes. So break these two apart and then subtract them from each other. And then we will only want to look at the C part of this here. So you can just break this open and look at the C part. If this is greater than 0, then we want to add this to the rotation, the roll part of the rotation of the current upper arm here. So you want to break this open. Oops. Combine this in local space, meaning that we need to do it like this, with only add in the roll part here from the C component here. Disconnect this and split this open, connect up the rotation and the location again. So I need to move this over a little bit, it seems. Let's do it same down here. So there's a little thing I forgot to do, I just noticed. We if this is getting negative, meaning that the hand is below the upper arm, then we don't want to do anything. So I'm just going to type in a max. So max between 0 and whatever value we get out of this, we're going to use. If we just hit play now, we will see that it's rotated somewhat upwards now. If you just remember how it looks here now versus if we don't add anything, you can see it's more open. Hopefully you can see what I mean. I'm talking about this angle here, and connect this up again. And now you can see it's rotated. This should make it look more realistic. And if you want to, you could even type in a factor of something, something like this. I don't know if I'm going to use 1.2 or whatever, but it would. You can see it adds a little bit more rotation to this. Actually, I don't think I added, when I tested this out, I added anything, but so I'm just going to leave it like exactly like this. All we need to do now is just to replicate this to the other arm, and then we can address a few more things before I probably should end this video here. It became a little bit longer than I anticipated. Bring this over, disconnect this, split this open, connect the rotation and the rotation, and we need to substitute the left hand effector with the right hand effector in world space, and the left upper arm with the right upper arm in world space. There we go. This should work. Okay. So, final few things. If we go into the SetShoulder, we have a place here with at the beginning, where we can push the body forward and backwards. I just wanted to point this out because when I was testing this, I kind of suddenly felt that the body was not placed exactly where I wanted it to be. And what I talk about is, let's see. When I look down, can you guys see this at all? Yeah, when I look down like this, it's sometimes like the body is a bit too much forward, and by changing this to, for example, like 12, you can kind of push it a little bit further back. It's a little bit hard to see, but this is definitely a value that I would suggest you play around with yourself and see if this feels a little bit more natural. I think it does something to the way that the shoulder is positioned. At the moment, what happens when I look at my arm, you can see right now it's like my shoulder is, or my elbow is supposed to be down where my hand here is, but as you can see, it's completely off. And that is because you can see the body follows the rotation of the head quite a bit at the moment, which is, it's not wrong, or but it's as you know, it's an approximation. And what I'm going to do here is to change the approximation a little bit and give the hands somewhat more influence. So changing this part here to have 0.7 influence coming from the hands instead. It causes some other issues, but I think this is a more correct way of doing it. Plus, it's a little bit more true to the way the original implementation was made. So now it's not any bit better, I think. Well, what? It's actually a little bit worse. I don't know. You can play around with this yourself. One last, did I say last thing before also? I have one more thing I wanted to also change a little bit, and that has to do with the reach of your arms. Currently it seems like the reach of your arms, or my arms at least, does not fit. So the way we can tweak this is to go to the, if you just go into either the left or the right arm here, and where we have this RotateUpperArm, we have these values here which we set previously. I'm gonna change these to 30 instead of 20. So I'm just gonna change the comment here as well, because this is the same. And this is 33. I'm gonna change to 45. This is the same, just changing the comment, and this is 45, changing the comment. Oh, and down here as well. So it's actually a bad idea to have these comments here, because the moment you change these, they are not valid anymore. Maybe I should just delete them, now that I think about it. Oops. Okay, the values, or these here, I will also like to make them public, so it's a little bit more clear that they are a sort of a setting variable. So these two I'm making public. The offset angle is technically also a setting, and this, and the weight also here, and the elbow rotation speed is also, and the clavicle offset also. Let's see, this one. Well, this one actually has a variable of a default value, which is 150. I think it's because I duplicated this value here. It should definitely be 0, so it's not confusing anyone. Left, this is okay. So we have a number of variables now that we promoted. Oops. So what that means also is that when you hit simulate or do whatever, once you click your character and scroll down in the details with the hierarchy of the components, select your UBIK component. You can see here you can actually tweak these live now. So this just makes it a little bit easier to figure out what works best. Yeah. Anyway, if we just do a final test here via preview. So what the changes we just made here, it should mean is that when I reach forward, the arm should maybe see it from, whoops. Whey. Okay, I think I have a bug. I definitely have a bug. I think I know where though. Anyway, you can see you should be able to see that the shoulder here moves a bit further forward than it did before. It's a little bit hard to see. It's definitely racing, and it is moving forward. I can tell. It may be a little bit difficult to see on the video. So I definitely need to fix that bug I just introduced. That is the beauty of testing. And I must admit I didn't test this too thoroughly. I believe this has to do with the clavicle part that I just changed. It must be, I'm thinking. Let's see. So oh, that's kind of a shame. I was really happy with this. Yeah, well, okay. Guess I will have to do this. Inside the set left upper arm, and that means also the right upper arm, we are going to have to throw away this stuff we just made and do a full conversion. So this we need to compose with a shoulder transform in world space, because this is a shoulder transform, or shoulder space transform, and this is the shoulder transform. So now we get it back into world space, and then we will convert this again now what we are going to do now with this, we are going to take this is the upper arm. Yeah, so we break this and we get the hand, not the hand, the shoulder in world space. I believe, let me just check something. No, because I did this wrong. Well, we have to do this vector minus vector here. Let's see. Yeah. So you can see the right is off, but the left is now working again as it should, I think. And I might have pushed the body a little bit too much back. I'm actually going to go back to my original 9 here. I don't like those 12. It seems like it's too much back. So if we just replicate this stuff here for the right shoulder, then we are done this time here. So I apologize for the mess up here, but that's what happens when you record live, all kind of trying to do things without having tested everything thoroughly. So anyway, shit happens. Okay, so what I did was to go into the set right upper arm, meaning this one, from the right upper arm in shoulder space, convert it into world space, do the delta between the shoulder and that location, do the rotation, convert it into component space to get the right clavicle. Now we should have a working right arm as well. I'm not too happy about the snapping though. That is one area that still bugs me a little bit. Okay, I think I'm okay with this. It's definitely working better than before, I think. So I am gonna commit this to the repository so you guys can try it out. Feel free to leave comments on the video if you find errors or have questions to it. Just post whatever you want. I will see if I can address them in the comments. So for now, thank you for watching, and I will be seeing you